Now we are going to talk about multi-factor authentication. And if you're wondering what multi-factor authentication is, it's the use of more than just one credential in order to enter into a protected system. So, why do we care about something like that? Well, if you think of a password and even the combination of a username and a password, this is something that you know. So a password is, because it is information, it can be shared between parties. And the security that's involved with that is obviously compromised whenever somebody either on purpose or inadvertently shares the information and the password is no longer secure. And because this is something that can be so easily transmitted or easily lost, easily forgotten, or just easily duplicated and used to enter a system, we cannot be certain that when somebody is using a password that they are who they say they are. And this in the past and even in the present has led to a lot of high profile vulnerabilities and breaches where passwords got exposed. And we have talked about password complexity as well. So if somebody has a password which is too simple, this can lead down a path of exposure. And that could be exposure for the person whose password got figured out, and also for the company for who they work, and even sometimes the services on which they've set up their credentials, even if they are just a customer. So, one thing that we can add to this is a second factor, and that second factor is something you have. So, now the form that this can take definitely can vary. There are so many different tools, and we'll discuss a few of them in the varieties. And these tools allow you to have a second credential that you have to use in combination with your first credential. And the idea is that even if you lose some knowledge, so if you forget something, or if somebody else finds out something that you know, or there's any sort of leakage essentially of data between yourself and the outside world, and your password is no longer secure, the information on its own is not useful for in doing a intrusion or a breach, because the password alone is not sufficient. And what we have as a physical or perhaps digital second factor would only allow the person in possession of both things to enter. And the idea here is that very often you would be able to keep these two things separate. So, for example, you wouldn't print out your password and then keep it in the same place as you're keeping your physical token or digital token or some kind of a one time passcode generator, which we'll talk about. And that is a idea that is based on security research and a lot of field work that has proven out that adding multi-factor authentication does increase security and reduce the number of intrusions that happen on a system. And one thing that we can add to this, and this is something that's a little more advanced and something that you usually see in connection to very high security setups, and you're seeing this more and more in the consumer world. If you think about your mobile technology and some of the unlocking mechanisms that are getting introduced nowadays, and this is something you are. So, something you are refers to physical aspects of a person. So, perhaps your eye getting scanned or your face getting scanned, your voice being used to unlock a device, your fingerprints, or any combination of the above. And sometimes it can be very advanced, sometimes it can be simplistic, and very often that depends on what kind of a system we are talking about and how important the data is in there and how much the developers of the system have uh, restricted the access to the system based on having the correct biometrics. So, just as you can think of a password being complex or simple, so biometric scanning can either be very thorough, which of course means that it can be slower, or it can be a lot more straightforward because it's not comparing as many factors in the biometric analysis that it's doing. And when I say biometric analysis, that essentially you're talking about taking some kind of a scan of some physical property of yourself, like your fingerprint or your voice print or your eye or your face, and then running an algorithm over it to create a essentially comparable version that is then compared to something that's stored on record in the security. So, for example, if you're starting at a new job and they ask you for a voice print, then you speak a particular phrase, and that particular phrase gives the person recording it enough points on the recording, enough voice print data points that allow them to create a correct representation and being able to say with confidence that that's you, that's not a second person who happens to sound like you. And the idea is then whenever you come in and you have to identify yourself, you can replicate this consistently. So it's not like if you have a cold, suddenly you can't get into the system because your voice sounds hoarse, or you have a sore throat, or you're just not speaking loudly that day. The idea is that anything that is used for this third aspect here, something you are, it would be something that you can consistently produce, just like you would any physical token for something you have, or a password for something you know. And these three things sometimes are called the security shibboleth, and shibboleth stands for underlying principle or core principle. So these three things are core principles of security, because when you think about a digital system, there's not really a way for a digital, suppose computer or server or device to know who you are the way that suppose a person can know who you are, because as people we have evolved and have been brought up to be able to recognize other people and distinguish between other people. But a computer system only really knows you as potentially a user account in the data. So in order to identify yourself and consistently identify yourself versus someone else, it can definitely be a complex undertaking, and it involves some variation of these three factors. So when we talk about multi-factor, we are often really only talking about two factors. So for example, a username and password is one of the factors, and then something like a phone authenticator app or a digital key fob is another. And the passcode being entered from there is the second factor, and it's considered certainly secure enough for certain applications and then not secure at all for others. And that's why when we talk about multi-factor, sometimes that can actually refer to more than two and sometimes more than three as well. And the idea is that the more factors there are, the harder it would be for an attacker, somebody who has bad intentions, to be able to compromise all of them. And the idea is that something like a password is easy to transmit and reproduce, but then something like biometrics and then physical assets are harder to either steal at the same time or to coerce a person into using them. And so this is meant to discourage attacks that would easily be carried out if something was protected by password only. So what you see a lot is two-factor, and multi-factor is essentially an enhanced version of that. And sometimes there are actually systems that will selectively choose which factor they want you to authenticate based on, so that there's a key rotation policy in place. So basically, one time you'll have to enter your password and your a one-time security code. One time you'll get a phone call and you have to authenticate yourself by voice. One time you might be password and your security physical token, or sometimes it's a physical token and biometrics, so that it's never just relying on any one set of factors. And so let's talk about physical versus digital. We've already mentioned something like biometrics, and we've mentioned the possession of a physical key fob or another kind of physical token, like some are in the form of like a credit card that has a digital, a little readout on it that keeps generating new codes. And the idea is that we can have a physical asset, and the protection comes from the fact that it's physical. So, for example, it cannot be compromised at a distance. Somebody would actually have to physically steal it or duplicate it by having access to it. Without that, it would be essentially impenetrable. And this is, of course, on the one hand, great because now it has removed one of the potential attacks, which is just somebody coming into a database and grabbing a password or passphrase and then being able to use that, because now they would need to perform a second sort of attack, commit a second crime, which obviously is a little harder because it's possible to just go into some kind of credential table and grab millions of passwords, but in order to grab millions of physical tokens would require a lot more time and effort. But of course, the downside of that is that if somebody loses this, now they have to go through a separate, more involved process to get a replacement for it and reauthorize the new physical token. And that is, of course, by design, we wouldn't want it to be easy to get a new physical token anytime that somebody wanted, because this opens us up to social engineering attacks, which we've talked about, and people getting tokens when they shouldn't be. The digital version of this is when you have something like a phone authenticator app, and that app gets connected to a particular website or service through the use of a authenticated code scanning or phrase scanning. And then what happens is there's a synchronization between that digital authenticator app and the service that is producing its own passcodes. And this, of course, has some of the same issues as the other digital forms of credentials like passwords. But the idea is that since we're using two separate services for our digital tokens and for the credentials, that these two things, even though in the end they're combining to do one authentication, that since there's two separate methods of storage, that helps us to limit the attack vulnerability. This is how a passcode system works. The user has a laptop or desktop that they use to access a server, and then we have a phone in their possession as well. And those two things don't actually communicate directly, they communicate through the user's actions. And we have the security configurations stored on the server. And what happens is when the user signs up for an account and enables multi-factor, they will then get a web page in their account where there is something like a QR code, and they are asked to scan the QR code into their Authenticator app, and that passes along some information, and the information is based on one of a couple of algorithms that we'll look at. And those are then used to synchronize the server and the phone. And what happens is they both are able to generate the same passcode at the same time. And because of the synchronization, without needing a separate connection between the two to keep the synchronization consistent, we are able to have a complete second factor. So the user has password and username, and then there's a phone which is not connected to the server that is able to provide a limited time. So essentially it's usually like a minute or so that a particular passcode generated there is valid. So they're able to use that ephemeral temporary passcode to get in. And one of the algorithms is called HOTP, or HMAC-based one-time password algorithm. And that is one where there is a original phrase, or it's essentially a string of characters that is used to seed a algorithm that is shared between the suppose phone and the server, and then the two things are able to use, since they're starting from the same point, from the same series of characters, they're able to over time consistently produce the same codes. And this is a very interesting thing if you think about it, that two things are doing the same series of computations over time and are able to have matching results. And this is what the whole multi-factor authentication is really based on. There's a second variation, and that is time-based one-time password algorithm, and that's where the current time is being used as well as the algorithm. The combination of the current time and algorithm are what producing the codes, which are shared between the server and the phone. And when I say shared, I just mean they're producing the same one, but they're not actually sending it to each other. They are being used independently, where the phone produces it, the users enter it, and then the server says, that's the same code that I had at this time, so you're allowed to come in. And so the idea here is, if the two things fall out of synchronization, with the system clock one place starting to drift from the system clock in the other place, these codes might no longer match, and so sometimes some resynchronization is needed, where the user has to make sure that the system clock on the server and the system clock on their second device are the same, they're synchronized.